Bismillahirrahmanirrahim. All right, let's start with the important things first. Now, for the midterm exam, I have received the copies actually, especially from the female branch, actually late. And in my way of grading to make sure that I try to be as fair as possible, I grade question wise. That means question 1, then question 2, then question 3, all papers. So this way I find it to be more fair to everyone. So the grading started late, so the grades are going to be uploaded, inshallah, hopefully. I hope by the end of this week or the beginning of next week. I hope, inshallah. So this is the first part. The second thing is that if you see here, actually this is a little bit updated from what you've seen a long time ago. And actually, even in the recent, even yesterday, I just made a change. Now, I was trying to squeeze as much as possible, but then looking deep into the topics, I found that some of them are actually requiring some time. I didn't want to speed up things just because we were rushed by the HEA and by taking an additional week for the midterm. So I'm going to cover only 4.1. Now, if you checked more, that's actually, it's going to be a good thing because you're going to be ready for next. The other thing is that if you look at the resources, I'm planning to split this 4. This is the old one. I'm changing a lot of things in it and I'm adding these ones. So I just finished this 4.1. I just uploaded it here. And yeah, so it has more than what you have what you had before, so I suggest you download this one now if you if you're looking at the slides from the previous version, the full chapter. Yeah, what else? And the last thing, yeah, is this, because we lost a week. We were having every week we were having mini tests, so now we had to change the things. Actually, I was initially planning to put one mini test to be 4, and then I thought that it's better to just have 4 mini tests of 2.5, 2.5, 2.5, which is going to be enough, inshallah, hopefully without any interruptions, to be able to finish those. The other things, on top of the others, what I changed also is that I added the weeks that are going to be covered in the quiz 2, because now we are week 10, next week is 11, and then we're at the quiz 2 in the week 12. So what are the topics that are going to be covered? The topics from week 7, 10, and 11, which means this, and this. All right, so today we will be having the mini test 5, which is the week 7. This is going to conclude the 5 mini tests, which will allow me to group them all and give you a grade for the assignment 1. So these all 4 ones. 2 plus 2 plus 2 plus 2 5 times, it's 10. That means it's going to be for the assignment number 1. So after this one, we're going to be having the assignment number 1, inshallah. You're going to be having the grade for assignment number 1. That's what I mean. I think I finished the updates from my side. Do you have any questions or questions based on what we had last time? Something that you would like to clarify based on what I just said? Just go ahead. And while you're doing so, I'm just going to start with this while you're getting ready to find some questions, if you have any. All right, I didn't hear any blip, which is generally what happens when someone writes something or says something. When will the midterm grades be released? I think I addressed that, unless you just came late before addressing that, but the idea is after this weekend, hopefully, if I have time to work during the weekend, or the early next week, inshallah. All right, I will also make available this solution once inshallah I grade everything, and I will make available the solution to you, the answer key, so you'll be able to check that. And we'll find, and maybe I'm still discussing to find a way to show your papers, and I'm still trying to find the logistics about it, to send the copies to the female branch, for example, and have you, for those on the male branch, to come to me. For female students, will most likely have their copies that they can check somewhere. As soon as I finish the grading, I will send the copies to the female branch, the hard copies. I don't know exactly the logistics. Once I have more information about it, I will let you know, inshallah. So today, the topic of this week is divisibility and modular arithmetic. Now, this thing is actually not complicated, but there's a lot of terminology. This is what made me not go too fast on this week, and especially as we had lost 2 weeks. That means that's been a long time since you haven't had these lectures. So in order to make it less heavy, we're going to focus only on this part, the divisibility and the modular arithmetic. Now, these are actually having a lot of different parts in them, and we'll talk about them. But the idea is, this chapter 4 is actually about number theory, which is properties of set of numbers, and basically we'll focus more on integers. And this part here, we're going to actually talk about how integers can be divided, and when we divide them, they have this also the remainder, the remainder of the division, what is remaining after we divide, and this is the modular or the clock arithmetic, and we'll talk about that inshallah. These representations of integers, this is the second 4.2 that we're going to see next week, and the following weeks we're going to be talking about these prime numbers, greatest common divisors, and among other things, inshallah. So let's start with this divisibility, and the first idea behind that is that we can say that if a and b are integers with a different from 0, we say that a divides b if there is an integer c such that b is equal to a times c, which means that if b divided by a is an integer, because we said that a is an integer, b is an integer, and there's an integer c as well. So we say that a divides b. Let me maybe take this. My pen will make it much easier. All right. So we say that a divides b if there is an integer c such that b is equal to a multiplied by c. Now, the way to represent that is this way. So a divides b, that's how it means. This means if we write this, that means it is what does this mean? This represents that actually that b is going to be a multiplied by some kind of a c. We know that, a is not null, because if you have this multiplied by 0, it's going to give you 0. But the idea is that the c is also an integer, which means we can write any number that if we say that a divides b, that means we need to find that it's possible to find a number c that is an integer such that b is equal to a times c. And that c actually is going to be the result of b divided by a, which is just take this a divided by b, and that's pretty much it. So that's the idea. And if maybe you write it in the same direction, it will be less maybe complicated or less confusing. So from here we can just divide by a, it gives us this. Now what's important to realize is that we said that c is an integer, which means I cannot have like this 2.5. If I find a c that is not an integer, then a does not divide b. Okay, so let's have an example. Let's determine whether 3 divides 7 or whether 3 divides 12. So that means what we need to do, if we say that 3 divides 7, that means we can find a C such that 7 is going to be equal to 3 times that C, which means our C should be the result of 7 divided by 3. Well, we are pretty sure that this is not going to be an integer. Why? Because, I mean, this is going to be 6 plus 1 divided by 3, which is 6 divided by 3 plus 1 divided by 3. This is going to be an int, but this 1/3 is never going to be an int. So then we can see that, and this is its representation, 3 does not divide 7, while if we have this is 3 divides 12, it's going to be the same idea. And as we can also say that we can find that C, that is B divided by A, and we just find out if that we do the division, and then we find out that actually if you take 12, we divide it by 3, is this going to result into being an integer? If yes, that means okay, that's right. So this is going to obviously give us 4, and then this leads to, yes, 3 divides 12. So a very basic thing so far, just a new introduction to a new way how to represent things, saying that this divides that has some kind of like property that we can find a number, an integer, such that that B is going to be equal that C. So if we have such thing, we can conclude that actually A divides B. And basically we can just, if you get lost on okay which one is which, well, look at this. If you just have this, what we do is we divide B by A. So that means A divides B. So that's the idea. Or B is divided by A. So we read it this way: A divides B. So this way, so you won't get confused, inshallah. Now, once we have these, there are some properties, some theorems that we can have. Like, if we have A divides B and A divides C, then we have that A divides B plus C. If A divides A and then A divides C, that means A is going to be dividing A, B plus C. Similarly, we'll prove this, inshallah, in the following slides. And this is what was actually one of the things that were missing in the previous slides that I just added. If another, let's say, property, if A divides B and A divides BC, like a number that is a multiplication between two numbers, B and C, and that means for that, sorry, I said if A divides B, then A divides B times any C, for all types of integers C that you can imagine. And that means we'll look into each one of them, inshallah. And then the last one is going to be if A divides B and B divides C, this is some sort of transitivity, then A divides C. We'll talk about that later, but let's have a look at this first one. So this is taken from, actually, let me just, I think he won't be able to see it because there's this thing that hides it. Okay, for some reasons I'm not able to. I'm not able to move it. What I'm trying to show is this. There's a link here. If you click on that link over here, it will take you to the video from where I took this. And that video is actually the same as the one that I mentioned a couple of times ago. That shows actually some very simplified explanations that I actually like. So now we said that the first thing we're trying to prove is this: if A divides B and A divides C, then A is going to be dividing the sum of this B and C. So let's prove that. So what we did, this is like some sort of an examples to show that. That means if A is 3 and B is 15, and then C is 6, for example. So 3 divides 15, right? Because if we have 15 divided by 3, this gives us 5. So it's there's a number, there's a c that is an integer that is going to be giving that thing, making it correct. Same thing for here, 3 divides 6, which means now this is going to tell us if we have these two, that means we can have that 3 divides 15 plus 6, which is 21. Now, similarly, 21 we can find an integer c such that 3 times that 6, that's c is going to give us 21, which is in this case 7. If we multiply 7 by 3, it gives us 21. So now how to prove that is basically, if we say that a divides b, that means we can find an s that is an integer such as b is equal to a times s. Basically, this is the definition of what we said, the divisibility. That if a divides b, that means there is a c such that b is equal to ac. That's what we said. So based on that, I can just say that a divides b gives us this. Similarly, a divides c gives us this by the definition of this divisibility. Which means now, if I take this b and I add c to it, b plus c, what I'm trying to do is I'm trying to find that this is going to again be the same pattern. I'm trying to find that like this b plus c is going to be equal to some integer x, let's say, multiplied by this I, by this a. Similarly, or just maybe let's follow the same format, which is going to be like a times some kind of x. X is being an integer, so that's what I'm trying to reach. And if I do that, if I show this, okay, that means a divides b plus c. So now what I'm doing, I have the b equal a s, c equal a t for some t, and then by doing the addition, I'm going to read this is as plus at, which is going to be a multiplied by s plus t. And this is our x. That shows that b plus c is having something that multiplies that x. Hence, this is a symbol that this is what we need to prove. Hence, that we have like a divides b plus c. I think so far still okay, right? If you have any questions, please interrupt. Now let's prove the second one. The second one says that if a divides b, then a is going to divide b multiplied by any integer c that you can put. So let's have a look at that. Now this is again some examples. If 3 divides 15, and now that means 3 divides 15 times 2. 3 divides 15 times 3, which is this, or it seems to say 15 times 4, and so on, whatever you put in there. And any number is going to be doing that. And then again, to prove that, we're going to again do the same thing, assuming that if a divides b, that means there is some kind of an integer, let's say t here, that is going to be equal to a times t. Now, if we multiply some number, any number c by here, that means we're going to have bc multiplied by at and then multiplied by c. This is going to give us this. All I have to do is to, because of the associativity, I can just move these parentheses around and then say that, oh, see, bc, that means is going to be divisible. A is going to divide bc because I can find that there is some kind of, again, some x, some number that is going to be b plus bc equal to a times that x. And that's by definition of this divisibility. We get that now if a is dividing b, then a is going to divide b multiplied by any integer c. So we've seen that we proved the first one and the second one. Now the last one is that the transitivity one. If a divides b and b divides c, then we're going to have a divides c. Okay, let's see how this works. So this is what we try to prove. And now an example to show that is that if 3 divides 6, right? Because we can find a number that multiplied this 3 by is going to give us this 6. And then 6 divide 18, which is, again, we can find a number that is going to multiply this 6 and give us this 18. This number is an integer, I should mention, yeah. So that means now what we try to prove is that 3 is going to divide 18. So 3 divides 6, 6 divides 18, that means 3 can divide 18. So to prove that, again, same formula. We have only one way to represent A divides B, is by saying that there's some sort of a number t, such that B is going to be equal to A times t for some t. And then since B also divides C, then we can have another integer S, such that C is going to be equal to B times S. And then all we have to do is to replace the B here with what we have here. So that means now C is going to be equal to AT times S, or again move the parentheses around and we will get that C is going to be equal to A times some kind of an integer. And this is the definition of divisibility. So we've shown that once we have divisibility, we have these three properties. That if we divide A divides B and then A divides C, that means A is going to divide the B plus C. If A divides B, that means A is going to divide any other multiplications with that B of any number, with any integer numbers. And then if A divides B and B divides C, then A is going to be dividing that C. Now let's have a look at this. If A, B, and C are integers where A is not null, such that A divides B and A divides C, then A is going to divide MB plus NC, wherever M and N are integers. I don't think, okay, let me just, I don't think we're going to have a look at that for now, because I think there's some kind of anyways, I don't want to spend a little bit of time on this, because I'm not looking at I'm trying to think about the applications, if we have some exercise about them, and yeah, I don't want to give you too many things. Actually, we can infer that, but okay, I don't want to spend too much time on that, because I want now to talk about the other part. Is there's something called the division algorithm, which that division algorithm is going to tell us that when an integer is divided by another integer, there's always, now we said before that an integer can divide or not divide another integer. So if it divides, it has some properties. Now we're talking about dividing any possible integer. That means if either it divides, it's divisible, or it does not divide. If we do the division, we can always write that division into some sort of, using a quotient, actually the T is the quotient, and the remainder. So that means every time you divide, let's A and B be integers, then there is always a unique for every integer that you have. Choose any number. You can always represent that number with this, in this format, plus R. Now, what is this? What is this D and what is this R? Q is the quotient. R is the remainder. And D is that you can find there is such D such that it's going to be, A can be represented with the D equal to Q plus DQ plus R. Now let me just maybe give an example. I don't know if I have made an example here. Yeah, maybe we did. Now, if we represent this, that means what we are trying to do is we'd like to give the quotient and reminders of this. 7 divides 18. What does it mean? 7 is, if I'm asking is 7 divide 18, that means I'm looking to see if there is any integer such that 18 is going to be 7 times that integer. Let me just remove that x and call it, sorry. Okay, remove and call it this integer a. Now, can I find a number that is going to make this? Well, now the thing is, I need to write this in a way that is going to actually have some sort of representation that looks like, I mean, maybe I shouldn't have used the 8, might be misleading a little bit, times some kind of c, let's say. Multiply this with some kind of c, and it's going to be representing the number. Now, this is obviously not the case, because you cannot, 7 does not divide 18. However, I can still represent this division using this, dividing this 18 by 7 into a quotient and remainder representation, which means I'm going to say that this 7 is going to be represented by, so this 18 is going to be 7 times some number plus some other number. Now, what kind of other number that we can find? If we have such thing, now with this format, you can tell me what Q can be and what R can be. So in this case, 7 times 2, for example, gives me 14. So that means this can be equal to 7 times 2 plus, now it is 14, that means I need to add 4 more to make it 18 to be like this. So now that means this Q is 2 and the R is 4. Therefore, I can always represent any division between two integers, regardless of they are divisible, this number 7 divides that 18 or not. In this case, it's clearly does not divide 18, but I can always have this quotient and remainder, the remainder. This is a mistake. I mean, that's why I always try to used to call it remainder. That's why I will always still try to, remove that and correct myself. But it keeps coming back. This remainder, that's not reminder. It's remain. What remains actually. This is from where it comes. What remains from the division. Now, if we just try to do this, okay, if we divide the way that we used to. I mean, this is the way that I used to. If you divide 18 by 7. So what we used to do is to have this 2 times 7, that's 14. What is remaining is 4. So this is actually basically the result of that. This is representing this 18 is going to be 7 times the quotient plus the remainder. Now the quotient is this 2. This is what I divide by. And then the remainder is this 4 over here. Now this being said, your turn now. I mean, it's a little bit tricky, but you can do it. If I'd like to have 112 be represented as 10 times some quotient plus R, what would be Q? What would be R? Your turn. I'm waiting for the beeps. Okay, heard the first one. Q and R. Q minus 11 and R minus 2. Okay, somebody else? So we have Q minus 11 and then minus 2. Somebody else? Another candidate for this Q and R? So same, okay. Minus 12 and 8. And then 8 plus 8. Okay, minus 12 and plus 8. Okay, something new. Okay, anything else? Minus 10 and minus 12. Okay. minus 10, and then minus 12. All right, and this is actually what I was looking for. Not because it's right, but because it's right, but because I did not mention one condition that will make it not right. But for what I said, this is a correct answer so far. Yes. Okay, anybody else? Okay, so let's do this. Minus 112 divide by 10. Obviously, this is going to be, if I use 10 times 10, that's 100, right? So this is going to be fine. However, there is a condition that I did not mention, which was part of here. This remainder, it has some kind of property. The first one is that it's positive, or 0, but it's positive. The second one, that it's less than the number that I divided by. So it's smaller, strictly smaller. So let me just go back here. So what I'm trying to say is, now in this here, my quotient, if we said that it's 10, so R we said should be strictly positive, which means these two, even though technically correct, but with this new condition, they don't qualify because R should be positive. But I need to have a limit, and that limit should be the D that I have. What is this D? I mean, this is the thing that I should have. Because if I'm dividing, let's say if I'm dividing 8 by 2, or maybe by 2. So it can be 4, right? But what about I say, no, you know what, I'm not going to divide by 4. I'm going to say that 8 is going to be equal to 2 times 2 plus 4. 2 times 2 plus 4, right? So, but 4 is actually 2 times 2, or 2 plus 2. In this case, it works both ways. But that means I can still, this remainder can still be used to divide. So I did not divide to its full capability of this division. So I should, when I divide, the remainder should be something that I cannot divide anymore. So basically what I should do, if I divide by 2, this should be the maximum that I can have, which is 4. And then the remainder here, the remainder is going to be 0. So I'm not going to divide by 2 and then add to the remainder. That's why we said that the remainder should be smaller than what we have, and it should be positive. So in this case, because of this here, I cannot use, I mean, basically the 10 and then at 12. This 12 has two problems. The first one, it's not respecting that R is bigger than 0. And on top of that, it's not smaller than the 10. So this is correct technically, but now that I added this condition, or these two conditions about the R, now the only one that is acceptable is going to be, let's remove these, is going to be this one. But let's check it. Is this right? Now if I have this being minus 12 times 10, that means minus 120. And now we have this 112. What is remaining? Yes, we can add this 8. So that means minus 12 plus 8 is going to be, so 10 minus 12. This is going to be the quotient and remainder representation of this 10 divides minus 112. I hope that, I mean, I didn't want to give you everything in once, so now let's go back and revisit this division. It's called the division algorithm. If we have an integer and d as another positive integer, then there is a unique integers q and r such that r is going to be positive and smaller than the number that I used to divide with, and this is actually the number that I divide with, the d, such that a is going to be equal to d times q plus that r, and that's the remainder the remainder, sorry, the remainder is always positive. Always positive and always smaller than what I divide by. So that's, okay, so that's the thing here. The last one is, what about this one? So we said that, again, 14, does it divide 0? It means 0 is going to be equal to 0 times 14 plus 0. So both the Q and R are going to be zeros. All right, so I think I also include this here. So you can have the solution there. For this here, see, this is going to be fine. However, it does not respect now the condition if we use minus 11 as a way how to find the quotient. So it doesn't work, which means we need to up by 1 in order for us to have this positive R to be positive, and it's important that we keep it. That means less than 10. Because now someone can say, oh, you know what, I can multiply by 13, minus 13. And then this is going to be minus, plus, now a bigger number. So because we can always represent, let's say, this 10, if you divide by minus 112, in this division algorithm represented this way of having like minus 112. This is equal to 10 times minus 13, which is going to be equal to 130. So plus, I just need to add what? 8 plus another 10. So that means I can add 18. Now this is, I mean, valid in terms of the way how to represent this, but this is not what we're looking for, because this should always also be respected, and this remainder does not respect that. So that's, this one is going to allow us to have a unique Q and a unique R for every integer that we have. And that's the idea behind that. I hope it's okay. Now, this way how to represent this, they gave them some names, and again, this is, I just need to not get confused. Divisor, this is the D that we used. We said that is going to be, right, A divides B. That means I can represent that B is going to be equal to A times this quotient plus R. Now this thing that I divided by, I mean, this, they call it D, so this actually is going to be this D here. This is the divisor, which is going to represent it like this. That means this quotient is going to be, I'm trying to not confuse you, but I seem that I just did. Okay, so let me just use the proper letters that are not going to be confusing. So we said that the division algorithm, that what we've seen, D is called the divisor, or divisor probably. I'm trying to be. So here we said let A be an integer and D a positive integer, then there's a unique Q and R such that A is going to be equal to DQ. So this D here is called divisor, I think, or divisor. I think divisor is a divisor, and A is called the dividend. D divisor, A dividend, and this is the dividend, and this one, the D, is the divisor. Now there is also a representation of that, which is the quotient here. Q is called the quotient, is going to be the result of A div D. What is A again? Remember we said that A is going to be equal to D times Q plus r. A is the number, the integer that I'm trying to divide. So if I divide A by D, I'm going to get Q, regardless of the remainder. So the remainder, we don't care about it here because we will get it from this mod. Now, A mod D, that means the remainder of the division of A by D is going to be this here, this R over here. So that's why this R is going to be, and if you're familiar with the Java, we used to use it this way, or modular division. This is what you call the modular division, or mod. And it's also called, the R is called the remainder, and to express the quotient and the remainder, so this is the way how to represent the quotient and the remainder. Div, that means we divide, we don't care about the remainder, and this is actually giving us the actual remainder. Remainder, what remains. So this is the percentage in Java. If you have like this 5%2, what you're looking for is basically you're looking for the remainder of the division of 5 by 2, which is going to be 1, right? Because 5 is going to be equal to 2 times 2 plus 1. So this is the remainder, what remains. And then if I do this int by int division, 5 divided by 2, remember int divided by int gives you an int. So this is going to be 2, which is this quotient that we're using. So here this is 2 by 2. So that's the idea. Now this helps you maybe divide int by int gives you an int, percentage gives you the remainder of the division. Yes, someone saying something? We will be having, yes, we will. I just said it in the beginning. And it's most likely going to be towards the end, inshallah. Another thing, so let's see some examples. Okay, what are the quotient and remainder of 101 divided by 11? So 101 is going to be equal to 11 times what? Times 10? Times 9? Why can't I use times 10? If I use times 10, this is going to be equal to what? So that means 110. What is remaining? Which is 9, right? Somebody saying something? 10 and 110. So is this? So I'm trying to write something. Plus, what's happening? It doesn't want to write anymore. All right, no more writing. Anyways, so let's. Okay, the bug. Okay, now it's back. Is it? No, I can't.
In this video, we're going to discuss divisibility.
Clicked on the source.
So I want to introduce some new notation.
I'm just trying to get this to stop. No way. Okay, end task. Okay, where is it? Maybe somewhere here. All right. So what I was saying is, yeah, we were here. What I was saying is that 101 is going to be some, sorry, this is the quotient. D is 10. No, sorry, this is 11 because we'd like to divide by 11. So this is our A, this is our D, and then we need to find the Q plus the R. So the Q now, I said, okay, what about this to be 10? If it's to be 10, now R should be what? and then I say that, okay, this 11 times 10 gives me 110. Now, what is remaining from, what's the difference between these two is 0, 1. That means remaining is 9. Well, and is it going to be plus 9? I heard something, okay. Yeah, I know, but what if, now my question, why this thing is not going to work? This 10 of me. Why is the 10 not going to work? Can you spot the issue? I can see it from here actually. That's why actually I try to divert from what was mentioned here. Okay, so can somebody tell me why this thing is not correct? Even though it looks like it's correct. Actually, there are two mistakes in there. Can you find them? Because we need to subtract 9, not add. That's a good point. So actually, this 110 plus 9, this is going to give me 119. It's not going to be 101. So all I need to do is to subtract the 9, which will make it 110 minus 9. This is going to give me 101. But we said that the remainder should be always positive. So by making it minus 9, it does not work. The other thing, it should be actually less than to this 11, because this is the D that I would like to have. So that's why it should also be less than 11. So this is not an option. Yes, and that's the issue. That's why this 10 is not going to be. So we have the answer here. That means the 9 is going to be the correct one. And if I choose 8, now the problem is going to be somewhere else, because 8 times 11, that's 88. I need to add, well, 13 to be able to reach 101. And this 13 is much bigger than the 11, which is my D, because we said that the R should be positive or null and less than the D. In our case, the D here is the 11. So the only numbers that are going to be possible, 9 for the quotient and 2 for the remainder. All right, so similar discussions here. So let's move on. Yep. Now let's talk about this modular arithmetics. The arithmetic. Now the idea about the modular arithmetic, this is the modulo division that we use in programming, for example. This is the general way how to talk about that. So in some cases we care more about the remainder than about the operation. And such cases, for example, most of the time you have seen that in Java we ask you to find if a number is odd or even, and we have to use the remainder. So in some cases we just care about the remainder. Most of the time this is what we do, just even and odd. But in real life, we will find ourselves actually dealing with more different scenarios. Like another example of those scenarios are like the hour. Now, if an hour has 24 hours clock, so that means what would be, if I add 50 hours from right now, what would be the time? So the time is not going to increase. It's just going to be either 0, 1, 2, 3, or until 23 in the terms of the hours. And similarly, if we just now assume now we'd like to work only with 12 hours, for example, now a standard 12-hour clock currently reads 11. So at this time we have 11. Okay, this is the time. Okay, that's not a good one. Well, this one is much better. So this is, we have 11, let's say, even though it looks like, okay, this looks maybe, anyways, you get the point. This is 9, 10, 11, and then 12. And it's pointing towards the 11. And this is our clock. Now, after 80 hours from now, what would be the time? Now, how do we do that? Well, basically, we just add this recurrent time to the 80 hours. So 11 plus 80, that's going to be, 91. So this 91, and then we just do the modular division, mod 12, because we would like to always, after 12, it just resets back to 1, 2, 3 until 12, and then 1, 2, 3, etc. So we're having mod 12, and this is going to give us the actual hour after this is going to be. Now, how do we know that? Okay, so we just calculate 91 divided by 12. So what would be the division of this? 9 is not an option, so it should be 8, right? Because 9 is going to be much bigger. So 8 is going to give us 8 times 2, 16. 8 times 1, 9. So even 8 is actually not good. And because 8 times 12 is going to be 16, and then plus 96, which is going to be bigger. So what we're going to do is the 7, actually, this 7. Now it looks weird. Is this the 7 that I'm talking about? Well, let's find out. 7 times 12 is going to be what? 7 times 12. 7 times 2, that's 14. 7 times 1, and then plus the 1, that's 84. Now, 91 minus 84 is going to be the 7. This is the remainder of this division, because this gives me 84. What is remaining, if I add 7 to 84, is going to be the 91. So even this one is actually not a good example, because it makes you, because this 91 mod 12 is going to be 7, but also 91 div, if you divide this by this 12, is also going to give you the 7. So anyways, that's but you get the point. The idea is that if this modulo or the remainder of the division is the mod, is going to allow us to among a set of possible values, just always go back to which one they are. Let's say, for example, have 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, etc. So 1, 2, 3, 4, and 5, and then we have minus 1, minus 2, minus 3, minus 4, minus 5, etc. So if I say, for example, I have something that it's either going to be 0, 1, or 2, that's, we have these three values. So this is going to be 0, 1, and 2, then 0, 1, and 2, then 0, 1, and 2. So each one of them is going to be 0, 1, and 2, 2, 1, 0, 2, 1, 0, and so on. So this modulo is going to only repeat for a certain number of things. We say 12 hours, that means it's going to be 1, 2, 3, or 12. That's it. We don't want to have anything more than that, and this is actually going to be given us to modulo division. Now, when we used to do in programming, most likely it's just odd and even, and we just use this modulo 2, mod 2, and just to give us, it is going to be 0, is going to be 1. There are two possible values for the remainder. Now, this actually remainder leads us to this congruence, and this congruence thing is actually something that I would like to talk about. However, I would like us to take a small break now with the mini test, and then we'll talk about this congruence later, because it requires a little bit more of your attention. So we take a small break, and then we take the mini test, and this is going to serve as the small break. So let me just put the usual "Are you ready?" question, just to, in case some have left. Are you ready for the mini test? Let's do it. Let me stop sharing my screen, if I can. Okay, close from here, and pause the recording. Okay, thank you, because I was just talking and my microphone was muted. So what I was saying is that in this modular arithmetics, what we're looking at is we're looking at like different numbers that are having the same mod. Now the idea behind that, let's say for example, let me just maybe take my pen again. Okay, let's find this again. All right, so again the bug. So I'm sorry to. This is disappointing. Close. Discard. Okay, Shift F5. And this time we're not far away. So we were here. All right. So what I was talking about is this here. Now the congruence is what we're looking for. We're looking for the numbers actually that are sharing the same result of the mods for some number. So let's say, for example, if we have these numbers, let's say 0, 1, 2, 3, let's go with 4 and 5, and then let's say -1 and -2. So I'm just going to go with something that you've seen and you used a lot, which is the mod 2, which is this when what we used to do in we get this mod 2. So what are all the possible values when we have mod 2? So it can be either 0 or 1, because we have two values. So that means the 0 is going to give me 0, the 1 is going to give me 1, the 2 is going to give me 0, and then the 3 is going to give me 1, the 4, 0, and then 1. And similarly, the -1 is going to give me 1, and then the -2 is going to give me 0, and so on. So it's only 0, 1, 0, 1, 0, 1, 0, 1. Now the congruence thing is actually looking at, this is the result of the modulo division, the remainder of the division, from these number by 2. So if you divide 2 by 2, it gives us 0. The remainder is 0. 3 divided by 2, the remainder is going to be 1. 4 by 2 is going to give us 0. 5 by 2 is going to give us 1. So that's the same logic, but this congruence is focusing on one simple thing. These, it's going really in the bad direction. These numbers here, see here, the zeros, and these zeros, and also these zeros. So the 0 here, the 2 and the 4, these three numbers, these 1, 0, 2, and 4, they all share the same result when we use mod 2. And this is what this congruence is about. So we say that A is congruent to B modulo some number if, this another result is going to be here if M divides A minus B. So that's another thing. So what we're looking for is that we can say, for example, is 2 is congruent to 4 in the world of mod 2. What we're trying to say by using this, we try to say that these 2 and 4, they share the same, they have actually the same remainder of the division. If you have the remainder of the division of 4 by 2, is going to be exactly the same as the remainder of the division of 2 by 2. In this case, it's our 0. So now, with this here, we have this definition that says, now if A is congruent to B in the word of mod M, so M was our 2, for example. Now this means that this M divides A minus B. Now let's have a look with the thing that we tried. Now our modulo 2 was, our modulo M here was 2 in the example that I showed. A was, we said like 2 is, this is congruent to 4 in the word of mod 2 in modulo 2. So this is what we said. A, like for example, we say 2 is congruent to 4 modulo 2. So that's what we're saying. Now this means that 2 divides 2 minus 4. That means this is going to be minus 2. And when 2 divide minus 2, what is the, is this true or not? I mean, obviously, this is going to be true. So does 2 divide minus 2? Yes. Does 2 divide minus 2? So instead of, for example, now this is easy for us when we use mod 2, but let's say I use mod 5 or mod 16. And I'm asking you, or let's say mod 12. And I'm asking you, is 7 congruent to 18 in mod 12? Now, for me in mod 12, it's not as easy as it used to be, as it was in mod 2, so it will be hard for me to find out. All I have to do now is just to check that if this is true or not. All I have to do is take this m, and I say, I need to check, does this 12 divide 7 minus 18? If that's the case, I'm going to say, oh yes, this is actually true, or no, this is actually not true. So that's what this congruence, this definition of the congruence and then its equivalency of this m divides a minus b means. So let's have a look at this here. So thus 7 minus 11 is going to be given, sorry, 7 minus 18, I just gave you the answer, is going to give you minus 11. So does 12 divides minus 11? Obviously, no, because they're going to be a remainder of the division, and this is no. That means I can conclude without a lot of work that 7 is not congruent to 18 in the word of mod 12. So that's basically the idea behind this definition over here. If we have this congruence, and this is how we represent it, if this A is congruent to B in mod M, that means if we have this, that means, okay, that's bad. If we have this, that means we have also that M divides A minus B. So in order for me to check that if these two have the same mod, all I have to do is to check that this M is going to be dividing A minus B. And if it does, that means this congruence holds. If not, then it doesn't hold. So okay, so let's see what we have here. So we use the notation A, this triple equals B mod M to indicate that A is congruent to B modulo M. We say that A is congruent to B modulo M is congruence, and that M is the modulus, this M is the modulus, plural moduli of modulus, the plural of modulus is moduli. If A and B are not congruent modulo M, we write with this striked 3 bars. Now let's see the example. Determine whether 17 is congruent to 5 modulo 6. Okay, that means we would like to find out if these are having the same result, the remainder, when we divide 17 by 6 and 5 by 6. Do they have the same remainder? So all we have to do, without doing too much of the verifications, is all I have to do is to check is that M in here is 6, is going to be dividing what? 17 minus 5. In this case, 17 minus 5 gives us 12. Does 6 divide 12? Well, yes, which means this is correct. And if we're trying something different, like 24 is congruent to 14, all we have to do is now take this 24 minus 10 minus 14, that's 10, and I'm just going to see that 6, does it divide this 10? Well, obviously it's not. That means it's going to be represented like this. That means 24 is not congruent to 14 in mod 6. Mod 6 actually. So that's another example, just to make sure that it's all understood. So in the universe of mod 4, these are the possible values. So it can be 0, 1, 2, 3. When it say mod 4, right? When it was mod 2, we said that the possible values are going to be 0 and 1, right? Because we have two values. Now in the mod 4, it is 0, 1, 2, 3, and that's the idea. When we ask this, what we're asking is asking these 2 and this 6. Do they have the same remainder of the division when we divide them by this 4? So 2 divided by 4, what is the remainder of this? Is it going to be, I mean, actually the proper way is to write here is 2 mod 4. Is it going to be equal to 6 mod 4? That's what I'm asking. This is what this thing is doing. If I'm saying this, that means this is correct. If I'm saying no, it's not, that means this is not correct. Well, in this case, obviously it's correct. So that's the idea behind that. And then, yeah, definitively this is actually the theorem that we are having right now is this. If we have this congruence, that means A mod M is going to be equal to B mod M, because this is how this thing works. That means we're looking at the A mod M, which is this first part over here. A mod M, this first part. When we're looking at this here, A mod M, is it equal to B mod M? This is what we're asking right now here. So the congruence means it works like this. However, now how to prove this? I mean, that's why actually I have some slides later on that I copied from those videos. But I just would like you to realize that this if and only if that if we have something like this, we need to prove that if P then Q, and at the same time if Q then P. So we have to prove it both ways. And let's go for this first one. So what I'm trying to prove is that if this, I mean, I'm trying to, yeah, I was looking at this here. So basically this here is actually some other examples explain that, so I shouldn't have added that. But for the theorem 4 that we're talking about, if we have, no, something, I missed something. This is theorem 3. Okay. Yeah, I think I'm the one that's been confused. So yeah, so this theorem 3, what it says is that if we have this, that means with these two, they have to be the same. So I don't know why I was trying to prove that. Yeah, I don't remember honestly why I put that slide over there. Okay, we have now Maghrib time. Discord, right? Yeah. Okay. Yeah, I should actually have timed the break properly with the Maghrib time. So let's take like 15 minutes to pray, inshallah, and then we come back at 7:15, hopefully, inshallah, and then we'll talk about these about these algorithms, right? So let me just pause the recording again. All right. Okay, so we're saying that these are these theorems. The first one is basically saying what the congruence is about, which is if A is congruent to B modulo M, that means A modulo M is going to be equal to B modulo M. I think this is what we showed. I was just trying to maybe show that here, this is what we can see, there's different examples talking about the same thing. So showing that these two is congruent to 6 modulo M. That means 2 is going to be equal to, like, this is the 2 modulo M. This 2 here is this 2 over here. 2 modulo 4 is going to give us the result of that is 2, and then 6 here, this one, 6 modulo 4 is going to be 2. So that means 2 mod 4 is going to be equal to 6 mod 4, and this is basically what the definition of this congruence is. Also, another thing that we've seen is that if A is congruent to B modulo M, that means A is M is going to divide M is going to divide b minus a, right? So this is also something that we have seen right here. I said b minus a also, okay, so I was 26, a minus b, sorry. So that's yeah, here. That's wrong. So this actually is a minus b. So this is a definition of the congruence. Okay, now the other thing is, we said that there's another theorem, which is that if m is a positive integer and a, b are congruent modulo m, if and only if there is some integer k such that a is going to be equal to b plus k dot modulo m, that m, k dot m of that m that we said a and b are congruent modulo m. So in this case, what we're trying to actually prove is that this a is congruent b modulo m if and only if a is going to be equal to b plus some k that exists, an integer k that exists times m. B plus k times m is going to be equal to that a, which is again, it makes, this is actually basically making sense. However, let's just try to prove it. And if we try to prove it, whenever you have this if and only if, this means that we need to prove from one side and then prove and the other side. So we're going to prove that if we have this, that means we can reach that, and vice versa. So to do this, basically, is what we're going to start with. So we're going to start by assuming that a is congruent to b modulo m, which means now a is going to be m divides a minus b. This is the definitions that we've seen, the congruence definitions earlier. And then because we said that m divides a minus b, that means this is going to be, there exists some kind of integer, we call it c or whatever, they call it k, which is going to make this a minus b is going to be equal to some k times n, this m over here. This is by the definition of this divisibility. We just said that if a divides b, right, that means there's some kind of that means b, or okay, not of clicking, b is going to be equal to some kind of a times c. There's some integer c that is going to be this. Now in our c here is this k over there, so this m is this one, so that means a minus b is going to be equal to km. That k, just some k to be an integer. Now if we do this, all we have to do is now to get to this thing is to move this minus b to this side, which is going to give us b plus km, and we just proved that doing if this then that, and we just proved in one direction. Now we need to prove now in the other direction, which means we're going to assume that we have this and basically work our way out until we reach that a is congruent to b modulo m. So now if we have this, basically you can just go backwards. So whatever we did here, we just go backwards, and then we're just going to find that this is that, it means this, which means then it's like that. So that's the idea, that's what we're trying to do. So assume that a is equal to b plus some km, then a minus b is going to be equal to this. This means, so that if you use by the definition of the divisibility, that means that m is dividing a minus b, because there's some kind of k that multiplies the m, it's going to give us this. And if we have this, by definition of this congruence, that means a is going to be congruent to b modulo m. So that's basically how we prove this over here. Now another thing is, we have, if m is a positive integer, a is congruent to b modulo m. If a is congruent to b modulo m and c is congruent to d modulo m, then a plus c, we take this, is going to be congruent to b plus d modulo m. So if we have these two congruences, That means if you do the addition of these two plus this one, and it's going to be actually the same thing with the plus this one. And it says also that it also work with the multiplication. You multiply these two, and it's going to be actually same thing. These two multiplied are going to be congruent to these two multiplied modulo m. And again, we're going to see how this how this works. It's basically very simple, same thing that we did before. So that means if we have this congruence, that means we can write it like this. We just seen that there is this algorithm that we just seen that if A is congruent to B modulo M, that means we can write, there's some K that we can write like this. So basically this is what we're trying to do. And if we have A congruent to B modulo M, that means I can write A to be equal to B plus some K multiplied by M. And then similarly, if with C, I'm just going to also have C is going to be this D plus some L, different K, so some L multiplied by M. Now all we need to do is to have this A plus C and to see what this thing does. So that means this is going to be this part. A plus C is going to be this here, this over here. And C is going to be this second part of here. So that means I'm just going to have B plus Km plus D plus Lm. And then just by moving things around, that means this is B plus D plus Km plus Lm. So this is just moving things by the associativity of the plus. And then I just take the M, which will make that now A plus C is going to be equal to B plus D plus M times some kind of number, which is going to follow the same pattern that we said. Now if we have this type of thing, so let's call this A plus C, this is now going to be this congruence. A plus C is one side, is congruent to B plus D modulo M, because that's the same format that we said here, except that this is X, for example, and this is Y. So we can say now this A plus C is going to be equal to this X over here, and this is the Y, which is this, hold on, what am I doing? K plus L, L plus M, which is, this is the integer. I don't know what this here, it goes more than that. I don't know, we don't need to do that. So okay, so we have that. So A plus C minus, oh, this is for the divisibility, I mean the divisibility of the congruence. I think from here we just I don't know what, I think this step is just unnecessary. If we reach this, that's it. So what we reached here, I think this is actually, I would like to clarify this. We reach this is equal to that, this part over here. Okay, let me just write it somewhere else, and just to show what I'm talking about. Okay, so I said A plus C is going to be equal to, I just showed that A plus C is going to be equal to B plus D plus M times some number K plus L. Now, just by having this, because we just said before, this here is a format of, that means A is congruent to B modulo M. So there's no need to go further more than that. Besides, okay, sorry. There's no need to go further. This is, let's call this, this is, let's say X, and this is Y. That means this is some kind of number Z, which is an integer. Now X equal Y plus M multiplied by Z. This is going to mean that X is congruent to Y modulo M. So now replace this X with this A plus C and the Y with B plus D, and then that's what we got. Well, that's what we're trying to prove. And that this here is going to be, just based from here we can find that. And yeah, so I think this whole step that was starting from here is not necessary. All we have to show up is this. Now, for the multiplication is the same logic. We just start with this means this and this means that, and then we just multiply the two. So that means here this is in the green part. Oh, sorry, in the green part. So we have this b plus km multiplied by d plus lm. This is going to give us b d. That's the first one, and then b lm. This is the one, and then we have km and d, kdm or km and d. And then this km lm, which is kl mm, because m is twice, that means m square. So this, now I can just try to take the m, make it outside, so I can have, this is some kind of an integer. That integer is going to be, now ac is going to be equal to this bd plus m times some kind of int. And this is again same definition that we is going to show us that AC is congruent to BD modulo M. So I hope I didn't bore you with these proofs, but the idea is that here, if we have A is congruent to B modulo M, that means A modulo M is going to be equal to B modulo M. That's the first theorem. The second one is that if we have A is congruent to B modulo M, that means I can write A to be in this format. A is equal to B plus K some M. And the last one is that if I have A is congruent to B modulo M and C is congruent to D modulo M, notice that it's important that we have the same M here in the modulo. If the M and N are different, that's not going to hold. So if this is the case, then A plus C is going to be B plus D modulo M, and same thing, if I multiply them, it's going to be the multiplication mod M. I think this is just an example about, the example is 7 is it congruent to mod M. Is this 7 is congruent to mod 5, sorry? So 7 and 2, do they have the same result of 7 mod 5 and 2 mod 5? Is it going to be the same? So okay, what's this 7 mod 5? And what is 2 mod 5? Can somebody tell me? 7 mod 5, I'll just divide 7 by 5 and see what is remaining. So I can have 1, and then what is remaining? 2. Now 2 mod 5, 2 divided by 5, well, basically you have 0, and then what is remaining is 2. Because you cannot, if you multiply by 1, it's going to be 5, it's going to be much more than what we have. So this is going to be 2 as well. So both of these are 2, which means that 7 is congruent to 2 mod 5. And now, same thing, we have 11, is it congruent to 1 as mod 5? Okay, 11 divided by 5 gives us 2, and then the remainder is 1. 1 divided by 5, sorry, that's not the correct division. Okay, 1 divided by 5, I don't know how you represent it, but this is how we use to represent division. And then this is going to be 0, and the remainder is 1. So yeah, so these two are correct. Now, based on the theorem, that means 7 plus 11, that's 18, is going to be congruent to 2 plus 1, that means 3, if in the mod 5. Similarly, if I multiply them, 77 is going to be congruent to 2 in the mod 5. So that's the idea behind this last theorem. Okay, let's do some exercises. I just would like to get into this thing. Let's just summarize, and then I'm not going to do them all because I want you also to practice on them, and so let's do some of them. So for example, I don't know, does 17 divide each of these numbers? What about this one? Does 17 divide this number over here? 3, 5, 7. Now how do I know? Well, how do I know if 17 divide this? Can someone help? Okay, but where is the here? Okay, let it go. So the remainder is 0, 357, but did you use the calculator? Okay, if I don't use the calculator, can I find if these two are, if this divides 357? Does it divide 17? 17, I said, not 15. Is there another way to find out? It divides based on the calculator. I'm thinking more about using something like yeah, I was thinking more about this division algorithm, for example, and to prove that if it's divisible, that means it's going to be some kind of remainder to be 0, which is going to, I'm going to find I can divide but give a remainder of 0. So anyways, this doesn't seem to be a very easy question to answer without the calculator. But let's calculate. 357 divided by 17. Oh, that's a word, 17. How many 17s do we have? 10. If I have 10, this is going to be 170. You have 20, 340, right? Is it? 17 times 2, that's 34. So that means 340. Now maybe I'm going to have 21 or something, because I have another 17 with 340. I have another 17, and it gives me 357. So without the calculator, I can say that this remainder is going to be, with 21, is going to be 0. Okay, what about something? Okay, something more interesting. What about this one? This one over here. -1 is divided by 3. What are the quotient and the remainder? That means 3 is going to be equal to -1 times q plus r. What the q is going to be, what the r is going to be. Am I right? 0 and 3. Is it? Q is -1 and then r is going to 2. Remember, the r has a property, it should be greater than 0 and also less than -1. This is the d, right? Well, my question was wrong. See, if you have to specify, okay, the way I said it actually was a little bit tricky because I was pretending that this is what we're asking for. -1 is divided by 3. What does it mean? Is that -1 is going to be divided by 3 is going to be equal to 3 times something. So this is what we divide for. We divide by 3, so that means 3 is what we divide for, some q plus r. So this is our d, actually is 3, not -1. And then the answer of q to be 0 and someone said 0 and what? 0 and 3. 0 and 3 is, does it hold? Because we said now r should be greater than or equal to 0 and then less than 3. So 3, 0, 3 does not work. Or does it? So what should I do? So I said that the r, okay, let me write it here, the r should be less than 3, bigger than or equal to 0. In this way, the 0, I will have to add -1 here, and -1 is going to make this not possible, because -1 r should be always positive. If I put 0, it should be -1. Now maybe that wasn't for the other question when I've swapped them, the 0, 1. So yeah, now if I put -1, yeah, again, so if I put -1 here, this means that it's going to be -3. I need to add 2, and it will become 1, and that's pretty much it. And again, I need to close this. This is really annoying. I don't know why, but it stops close window, not task. It keeps happening. Discard, and then shift F5. No, not there. Okay, let's go to the next one here. Okay, let's take one of these. 100 hours after it reads 6. So if we assume, obviously, it's 12 hours. So it's 6. Now I just would like to have 1 hour, 100 hours after that. That means this is going to be 106. Sorry, 106. And mod 12, which is, what is the remainder of the division of 106 by 12? So if it's 9, it's going to be 108. So 8 here. 8 is going to give me 8 times 2, that's 6. Aim times 1, that's 9. That's 16, I mean. Aims times 2, that's 16. But I'm just going to mark it 6, and the aim times, that's 8, plus the 1, that's 9, so 96. And I'm still having 10, so it doesn't work. So let's make it 9. 9 times 2, that's 18. Well, 18, that means 8. 9 times 1, that's 10, plus 1, that's 11. So it's not 9, so it should be 8. So what's the issue here? Well, basically there's no issue. 8 times is 16. The remainder of the division is going to be 10. There was no problem, because 10 is bigger than 8, but that's not what we're looking for. We would like to be the 10 bigger than the, not bigger than the number that we have here, because this is what we divide for. So then the answer should be 10. So this here, it should be 10. Let's see what some of you wrote. No? 4 is the remainder. It's a remainder with A, don't forget. Remainder with A, not I. Reminder, you remind someone of something. Remainder is what remains after you divide. So the A makes a difference. Actually, I used to just use this reminder, but this is not a reminder. It's a remainder, what remains. But I don't know what you're talking about, Q and R. This may be something else. You're talking about this 4 is the remainder. It's not 4 is the remainder, because we have 10 here, I think. And it should be that. I don't want to show the results, because, okay, let's show them. What is this? So it's going to be 10. So another method is what? I'm not sure about this other method here. Divided. This is dividing, maybe? It divides, and 8.3, this gives us. So 8 times 26. I don't know what that method, this is how it does it mentally, if you try to find a way. I know about this other method. Okay, how about this? Decide whether each of these integers is congruent to 5 modulus 17 or not. So let's take this one of the numbers. Is it going to be congruent to 5 modulus 17? I know that you remember that there's an easy way to do that, right? Let me just remind you of it. Where was that? Congruence, where is it? Here, right here. So we said that if A is congruent to B modulo M if M divides A minus B. If they have the M, it divides the A minus B. So if I'm asking you about two numbers, if A is congruent to B in mod M, all you have to do is check that M is going to be dividing the first one minus the second one. So let's go back. Okay, not this one, here. So we said, let's try this one. 103 minus 5, this is going to be equal to, so this is minus 3 minus 2, which means 100 minus 2, 98. So is 98 is M, which is 17. That's 17 divide 98. That means if you have 98, you divide them by 17. I'm not using the easiest numbers over here, so let's say 3, 4, 5, 6 times 7, that's 40, so that's too much. So 5 times 7, that's 35, right? 35, then we have 3 somewhere, and then 5 times 1, it's 5, plus the 3, that's 8. And then we subtract 98 minus 85, that gives us 3, 1, 13, which is below the 17, which means that's great. And because there's a remainder, that means 17 does not divide 98, which means this is not the case. Let's see. No, that's correct. All right. And it's not divisible, all right? So, yeah. Okay. I think there's something, the more exercises again, but there's similarly. I just would like you to just practice them. I'm going to stop here. I don't want to take too much of the time. Inshallah, by next week, inshallah, we'll try to have the break and the mini test around or just before the Maghrib time, so we can just have the mini test, then go pray, and then come back and continue for maybe half an hour or something like that, and then we finish, inshallah. Obviously, if we are going to take the break for Salah, we will finish a little bit or after 6 or around 6 or something, inshallah. As another like a reminder about what we said earlier, maybe for those who just joined, the midterm theory, I'm still grading the files as soon as, inshallah, grading the copies, I mean. As soon as I'm done, I will upload that and I'll let you know. Also for the mail branch, if you want to, as soon as I inform that, okay, the grades are done, you can come and check your answers if you want to. I will share the answer key once I do that, and then for the female branch, I will most likely send the papers to the branch, and then I'll let you know about how the logistics on who to contact and where to go about that, inshallah. And yeah, I apologize for taking too long, but actually that was not only my mistake. Actually, I received the files, the actual copies, I received them very late, and because I wanted to make sure that I grade question by question, which I think is the fairest way to go, because if you just grade the whole things and then sometimes your grading scheme changes on the way. So anyways, that's going to be it for today, inshallah. If you don't have any questions, feel free to go. If you have any questions, please show them.